As he said, I'm Chris Hauer. I'm a wildlife biologist at Fort Indiantown Gap. And today I'm going to be presenting some of the work we've been doing over the last few years, looking at the potential use of fire to reduce raccoon roundworm within Allegheny woodrat habitat. So if you're not familiar with the Allegheny woodrat, this is it. It's a medium-sized rodent that specializes in emergent rock habitats. So things like boulder piles, cliff faces, talus slopes, and even caves. Okay. Historically, their range extended throughout most of the Appalachian Mountains, from as far north as Connecticut and Massachusetts, all the way down into Alabama and Georgia. But within the last several decades, populations, particularly in the northern portions of that range, have declined to the point that they've become completely extirpated from Connecticut and Massachusetts and even New York. And there's only a single population remaining in northern New Jersey. So here in Pennsylvania, they're faring a little bit better, although not too much better. A recent statewide camera trapping study found that woodrat populations here in Pennsylvania have declined by about 70% since the early 1990s. And again, you can see kind of the progression over time with the orange triangles representing occupied sites and the white circles representing unoccupied sites. So you can see, obviously, from 92 all the way to 2002, there's far fewer occupied sites now as there were 30 years ago. So as a result, the species is listed as a threatened species in PA, and it's a species of greatest conservation need. So there's really three main hypotheses as to why woodrat populations have declined, the first of which is habitat loss and fragmentation. So as I mentioned, woodrats rely on these discrete rock outcrops and other habitats which are interspersed in forest. So as the surrounding forests become degraded and fragmented, woodrats aren't really able to disperse from one rock outcrop to another, which over time leads to inbreeding, depression, and loss of genetic diversity. The second hypothesis relates to reduced food availability, so particularly the loss of sources of hard mast, which they really rely on during this time of year. So previously that kind of attributed to the loss of the American chestnut, which was once a very reliable source of hard mast. More recently, it's kind of more closely tied to the loss and defoliation of oaks resulting from spongy moths. And then the third hypothesis relates to raccoon roundworm, which is, again, going to be the focus of my talk today. So what is raccoon roundworm? So it's an intestinal nematode of raccoons, hence the name. And again, this diagram on the right shows you the life cycle of the parasite. So the roundworms reproduce in the GI tract of raccoons, and then the eggs are shed in their feces. Those eggs are then consumed by a number of different intermediate hosts, including woodrats, when they forage for seeds and other plant material in raccoon feces. The eggs then hatch. The larvae then migrate through the host tissues where they reach the central nervous system, where they often result in death, or they can change or alter the behavior of the animals so that it's more likely to be predated upon, usually by another raccoon, and then that life cycle completes itself. Unfortunately, woodrats are particularly susceptible to infection because, unlike most other small mammals, they tend to cache whole raccoon feces in their den sites. So rather than just consuming the seeds right away when they first encounter raccoon feces, they will actually take it and store it in their dens for later use. And that gives those eggs time to become infective. What's worse is that the microclimate within those dens, which tend to be cool and moist, that allows those eggs to remain infected for multiple years. So even if a site becomes extirpated and you have new woodrats recolonizing that site, they can become infected as well, and that can continue for multiple generations. So here in Pennsylvania, raccoon roundworm is relatively widespread. So a study from 2014 found that statewide prevalence was about 33%, but obviously looking at the figure on the right, you can see that prevalence varies considerably by county. So a study from 2007 found that prevalence was as high as 58% in Indiana County. That's probably a little higher than most counties. A study from 2021 in Bedford County found that prevalence was about 10%, and some work done by a master's student at Letterkenny found that prevalence in raccoons there was about 7%. So clearly, raccoon roundworm is a threat to woodrat populations statewide. Now, how does prescribed fire factor into all of this? So a study from a couple years ago from Texas found that prescribed fire effectively killed nearly 100% of raccoon roundworm eggs in typical raccoon latrine sites, which is really encouraging, right? In that study in particular, again, it was very effective, or fire was very effective at killing eggs on the soil surface in areas with higher fuel loads and at distances close to the fire, as you would kind of expect. But it was much less effective at soil depth, so at even a depth of 2 centimeters below the soil surface in areas with lower fuel loads and at greater distances from the fire. Okay? So that kind of raises the question of, could we apply something similar to woodrat habitat? Again, this study was conducted in grassland habitat in Texas, so very different from the rocky upland forested habitats of woodrats. A number of other studies have also shown that raccoons tend to avoid recently burned forests, mostly because of reductions in forest structure and food availability. So that raises the question, can we not only use prescribed fire to kill the parasite on the landscape, but can we also use it to deter raccoons from using woodrat habitat in the first place? So that brings the objective of our study, which was essentially to evaluate the use of fire as a potential strategy to reduce raccoon roundworm within occupied woodrat habitat. And we really had two main questions that we wanted to address. The first of which, can a typical dormant season burn exceed temperatures needed to kill roundworm eggs on the landscape, which from laboratory studies is about 62 degrees Celsius or 144 degrees Fahrenheit. And so in order to test that, during a dormant season prescribed burn last spring, we measured soil surface temperatures at some of our woodrat sites. Our second question was, does burning actually reduce raccoon abundance? And in order to test that, we implemented something known as a before-after control impact design, very similar to what Dr. Leduc was talking about earlier. And we did that using camera traps where we compared raccoon abundance at both burned and unburned sites in the growing season prior to a burn and in the growing season after a burn. So our study took place at Fort Indian Town Gap, which I'm sure most of you are familiar with. And Fort Indian Town Gaps, which again circled in red here, supports one of the last remaining woodrat populations in the eastern portion of the state. So getting into the methods of our first study, again looking at prescribed fire and soil temperatures. So this study took place at 10 of our occupied woodrat sites, so sites that we know there are woodrats present. And all of these sites were located on the south-facing slope of Second Mountain, which is the mountain ridge that forms the northern boundary of the installation and is adjacent to State Game Lands 211. And so from the diagram on the right and the image on the left, which is of one of our sites, we placed I-button temperature data loggers at 4 separate locations within those 10 sites. So we placed an I-button at what I term the leading edge or the upslope edge of the sites. Basically, if we're working down slope, basically where the rock started, we place I-buttons at the center of the sites in and amongst all of the rock. We placed one at the trailing edge or the downslope edge of the sites where the rock stopped. And then we also placed I-buttons in the surrounding forest. Okay. So these were all deployed at these sites on the day prior to the burn, and they were programmed to take temperature readings every 2 seconds during the burn. So a little bit of information about the burn itself. So it was conducted last March and involves a number of staff from both our conservation office as well as the Game Commission. Our study area, which you can see kind of shaded in gray, was burned as part of our impact area burn. So just over or just under 2,400 acres in total. We started off with ground ignition using our Terra torch along the northern boundary of the burn unit. And then once we had sufficient black built there, then we brought in a helicopter which dropped dragon eggs throughout most of the rest of the unit. Oops, sorry. So on the day following the burn, we retrieved the data loggers at each of the sites, downloaded the data, and then calculated a few different burn parameters based on that study from 2021, which included maximum temperature, time to maximum temperature, And then the time the temperatures remained above 49 degrees Celsius, which is the lethal dose 50% or the LD50 for raccoon roundworm. Basically the temperature at which half of the eggs would be killed. And then also that 62 degrees Celsius, which is the lethal temperature at which 100% of the eggs are killed. And so the line graph on the right shows you the temperature profiles from one of our sites. And you can see those clear spikes in temperature as the fire passed through those locations at the site. So for our second study, again, we included those same 10 sites for this study and kind of designated them as part of our burn treatment. We also included 5 additional sites that were not burned as part of this study. And at each of these sites, we deployed 3 cameras and left them in place for about 4 weeks. And we sampled these sites, again, in the summer of 2024, which is the growing season prior to the burn, and then again last summer, which was the first growing season after the burn. In addition to camera trapping, we did some vegetation work at these sites as well. So we measured canopy cover, we estimated the percent cover of different ground cover types, and also measured tree basal area. And again, we analyzed these data using generalized linear mixed models, which I'm not going to go into the details of that too much, but we're basically looking at the effects of treatment. So again, whether a site was burned or not burned, time period, so basically pre or post burn, and then we also looked at an interaction term between the two. And this is really, I have this highlighted in red because this is really what we're keying in on here. So for this kind of study design, a significant interaction between treatment and time period would suggest that fire has an influence on raccoon abundance. So I will touch back on that later on. We also calculated something called latency to detection, basically the number of days between the initial deployment of a camera and the first detection of a raccoon. And then we also compared our vegetation cover between sites. So getting into some of our results. So this is, again, for the first study looking at fire and soil temperatures. So we found that soil surface temperatures exceeded that LD50 and the lethal temperature at the trailing edge and in the forest surrounding most of our sites. Okay, so above 50% of our sites. But you can see on the left-hand side, those temperature thresholds were reached at the leading edge and the center of only 1 or 2 of our sites. Okay. We found that maximum temperatures differed amongst those 4 separate locations, with the temperatures being highest at the trailing edge or the downslope edge of the sites, and temperatures being the lowest at the upslope or the leading edge of the sites. Kind of similar to that, we found a difference in the time to reach those maximum temperatures, with the temperatures, or the time is being recorded the shortest at the trailing edge of sites and the longest at the center, which is kind of what we would expect. We'd expect the fire to take a long time to creep through that rock. And then looking at how long the temperatures remained above those critical temperature thresholds, again, we found that the temperatures remained there the longest at the trailing edge or the downslope edge of the sites. Okay. So getting into the results of the second study, looking at fire and raccoon abundance. So we had a total survey effort of just over 2,400 camera trap days across both years. We had recorded just under 4,000 photographs, 341 of which were of raccoons. And some of the results for this, so we found a nearly 2-fold increase in the time it took to record or detect raccoons at our burn sites in the first growing season post-burn, which you can see on the right side of the box plot. But we also saw a relatively similar increase at our unburned sites as well. As we had hoped, we found a 62% decrease in raccoon abundance at our burn sites in the first growing season post-burn. But again, we saw a relatively similar change at our unburned sites as well. So when we looked at that interaction term between burn treatment and the time period, we did not find a significant effect. So that would suggest that at least in this study, fire did not influence raccoon abundance. Okay. And that may partly be because we didn't really find any change in vegetation cover. which kind of corresponds to what Maya presented earlier. So with the exception of percent cover of leaf litter, which declined at our burn sites post-burn, which obviously you would expect. Obviously that leaf litter is being consumed during the burn. And we saw an increase in the cover of bare rock, which again, as that leaf litter is burned, that bare rock underneath is being exposed. But we really didn't see any other changes in percent cover of forbs, woody stems, canopy cover, basal area, any of those things. So to summarize, our study demonstrated that a typical dormant season burn, which again is very typical of burning here in PA, can exceed the temperatures needed to kill raccoon roundworm eggs, which is positive. But obviously, as we saw, temperatures varied considerably within individual sites. So likely think that the use of aerial ignition combined with the very steep topography of our study sites, that created a more intense head fire downslope of our sites, which as that fire worked upslope, it's likely what contributed to the higher temperatures we saw at the trailing edge and in the forest surrounding most of our woodrat sites. Our results suggest that a backing fire may not produce sufficient heat intensity needed to kill raccoon roundworm eggs. And again, that was using a terra torch as opposed to just a typical drip torch. This may also be due to the fact that we had relatively low fuel loads at our sites. So all of these sites were burned 2 years prior to this study. And so again, we didn't have a relatively significant fuel load there. And kind of as we expected, fire is likely going to be ineffective at killing raccoon roundworm eggs on exposed rock. So if a raccoon latrine site were to be on a large flat rock surface, void of dense vegetation, that's probably not going to be able to hit those areas. And also in the case where raccoons have already cached those feces, it's likely that fire is going to be able to penetrate those dense sites, but that's kind of what we expected. For our second study, we found relatively little influence of fire on raccoon abundance, which contrasts a number of previous studies. Again, that may be because we just didn't see much of a change in the habitat, at least in the first growing season. It could be due to the fact that we just don't have a lot of raccoons in our study area. I'd say on average we had about 3 raccoon detections per site across both years. They were present. We did detect raccoons at every site both years. So they were there, but just in relatively low numbers. And again, that's pretty consistent with the literature. Raccoon densities tend to be low in upland forested areas, at least relative to riparian forest or urban agricultural landscapes. And also the fact that we had a very wet spring and early summer last year may have influenced our ability to detect raccoons. It's maybe why we saw similar trends in abundance. Just the precipitation reduced raccoon activity, or it could have reduced the effectiveness of our olfactory lure. So you saw in the photo, we baited each of our camera traps with a can of sardines to try to draw raccoons into our camera traps. So if the rain's washing away a lot of that scent, maybe it wasn't bringing in raccoons nearly as well. So ultimately, what does this mean for us? Still suggests that raccoon or prescribed fire may be a useful tool for managing raccoon roundworm, but it's certainly not going to be 100% effective at eliminating this threat. So I'd just like to acknowledge all the folks from our conservation office, most of which are here, as well as the folks from the Game Commission who participated in this burn. So if I have time left, I'll take any questions or comments anyone has. So thank you.
Given that you were burning through the habitat of a known sensitive species, did you have to take any precautions to reduce mortality of woodrats?
That's a great question. So her question was, did we have to or have any concerns about mortality of woodrats during the study? Not really. We didn't take any specific precautions. I mean, again, this burn was done in March. At that time of the year, woodrats are typically, they don't hibernate. They're active year-round. But at that time of the year, they're pretty much relying on hard mass that they've cached from the previous fall. And so we weren't really too worried about any mortality. And again, they're mostly active at night. Other times of year, it may be a little bit of a different story, not causing mortality by the fire itself, but changes in the habitat during other times of the year where they may be, actively foraging. It may have different impacts, but that's a good question. Any other questions?
Wait, you want the microphone? What's the trend according to for the population of the woodrat?
I would say, just based off our camera trapping data, that the population at Fig is relatively stable. And we partly attribute that to our extensive history of prescribed fire. Some previous work that we've done found that woodrat occupancy at some of our sites was higher at sites that were burned more frequently, to suggest that it's not having at least a negative impact. But it's relatively stable. We haven't really done a lot of live trapping, so we don't really know what the population numbers are per se, but we are working with the Game Commission now to do a little bit of live trapping to get a better sense of how many animals we actually have on post.
From an ecological perspective, what is the theory for change that would account for Raccoon roundworm if it is native now having a disproportionate impact or significance in the decline of our woodrat? So is it an increase in use of predators like raccoons or them coming into more direct conflict as a result of fire exclusion? Lay out any connections for me to help me understand why these are now a big issue.
Yeah, I think you nailed both the two main factors. There's just more raccoons on the landscape, and yeah, they're potentially because of just increased fire suppression in certain areas, that raccoons are probably more likely to move into those areas, particularly forested areas, that they would normally maybe not inhabit, or at least as frequently as agricultural suburban areas, yeah.
Over here. Although, when you showed the response of the vegetation, and it looked like it was primarily leaf litter that was reduced, what was the measurement interval when you did the response measurements? And can you just kind of summarize what the species were that you were seeing respond like that?
Yeah, I mean, we were just measuring that, again, the growing season prior to the burn, and then the first growing season after the burn. So, the burn was in March of last year, and then we were measuring that in May through September of last year. So that first growing season. In terms of species, we were seeing a lot of, in terms of woody vegetation, we were seeing a lot of sassafras primarily. We actually saw higher counts of woody stems at our burned sites than unburned. And that was, again, primarily due to, we had some really thick areas of sassafras regeneration, probably not resulting from just a single burn, but multiple burns over time. And so all of these sites were burned, I believe, 8 times over the last 15 or so years. And so, with the most recent burn being 2 years prior. And so kind of on average that 2 to 3 year return interval. Any other questions? Okay, thank you.
Thank you, Chris.